Pre-algebra, this is Mr. Rivers. I am out today. I'm going to go through today's new concept of solving equations using addition and subtraction. Following that, you will work some practice problems. Please give your best effort on everything you do, including watching the video, taking notes, solving problems. Make sure you're on your best behavior as well. Here we go. This is a little warm-up. We're not going to do the whole thing. I just want to highlight a couple things. Number one, we're going to be turning numbers into zero today. So if you're given the number -4 and you want to turn it into a zero, you got 4, -4 plus 4, we get a sum of 0. If we've got 4 and we want to turn it into a 0, you can subtract 4. 4 minus 4 is 0. What if we had like, I don't know, like negative 15? How can we turn that into a 0? We can add 15 to it. -15 plus 15 is equal to 0. That seems easy enough, but this is really like the cornerstone of this concept today of we're going to be turning numbers into 0 using addition and subtraction. Something else I want to talk about today is equations and what they mean. So something I've seen people do in the, well, I'll just dive in here. So if we've got like x plus 8 equals 7, what's on the left side of this and what is on the right side of this? They are the same thing, right? They are equal to each other. They may not look the same, but they are equivalent to each other. So if I subtract 8 from the left, that will turn that 8 into a 0, right? 8 minus 8 is 0. I have to also subtract 8 from the right, because the moment you subtract the 8 from the left, this equation is like out of balance. So you have to do what's called an inverse operation and subtract from both sides. There you go. So that's kind of the foundation of today. You have these notes right here, solving equations with addition and subtraction, inverse operations. Here we go. The subtraction property of equality. Subtraction property of equality. If you subtract the same number from each side of an equation, the two sides remain equal. I kind of hinted at that a moment ago. By the way, if I'm going too fast for you at any point in time, just pause the video, write down what you need to write down, then unpause it, keep watching. Subtraction property of equality, if you subtract the same number from each side of an equation, the two sides remain equal. For any numbers a, b, and c, if a equals b, then a is equal to b, right? But if we subtract c from the left and subtract c from the right, it remains equal. If you subtract the same thing from both sides, the equation remains equal. So let's take this idea and let's use it to solve problems here. We have r plus 56 equals -5. So the inverse of adding 56, we're going to turn that 56 into a 0. We're going to subtract 56. We're going to get the r by itself. So on the same side of the equation as the r is that 56. So the inverse of positive 56 is subtracting 56, and we do that from both sides. You have to show it on both sides. If you show it on one side and not the other, you're going to lose points now and forever. R is equal to -5 minus 56. We just had a test on this. It's -61. So you didn't know how to do that, like, I don't know, 2-3 weeks ago, but now you do. Let's try another one. 11 equals g plus 27. We're going to get the g by itself. What's on the same side of the equation as the g? That positive 27. Excuse me, sorry about that. That positive 27 is on the same side. So the inverse of positive 27 is subtracting 27. We want to turn that 27 into a 0. And we need to subtract 27 from both sides. 27 minus 27 is 0. It goes away. We're left with just a g on the right side. And 11 minus 27 is -16. Now let me show you something I did not do on the previous problem that I'm going to do here, and that's check my answer. So on a test or a quiz, if you have time at the end, what you can do is you can take your equation, which is 11 equals, and instead of g, we just figured out that g is equal to -16. So I'm going to plug in -16 here for g. We're going to add to that 27. You take your original equation, the variable goes out, the solution for that variable goes in, and then we determine, is 11 equal to, well, what's negative 16 plus 27? It's 11. It checks out. So what's really cool about this is, like, if you take the time to check your answers, you should know if you're right or wrong, assuming you don't make a second mistake. All right. We also have something called the addition property of equality. Addition property of equality. Make that a capital E. If you add the same number to each side of an equation, the two sides remain equal. It's the same thing, but instead of with subtraction, it's with addition. So for any numbers A, B, and C, if A is equal to B, well, let's put an A on the left, let's put a B on the right. If we add C to the left, we can add C to the right, and these two remain equal. There you go. That's the addition property of equality. We can practice this. We're also going to check both these this time. Here we have x minus 7 equals negative 10. So we want to get the x by itself. What's on the same side of the equation as the x? We're subtracting 7. So the inverse of subtracting 7 is adding 7. You want to turn that negative 7 into a 0. And if we add 7 on the left, we have to also add 7 on the right to keep that equation in balance. Negative 7 plus 7 is 0. That is eliminated, and we get x equals negative 10 plus 7 is negative 3. So x equals negative 3. Let's now take a moment and check that. Negative 3 minus 7 is in fact equal to negative 10, so it checks out. Very good. Let's take a look at this problem. 12 equals a plus negative 4. Again, we want this right side. We want the a by itself. What's on the same side of that equation as the a? We're adding negative 4. How do you turn a negative 4 into a 0? You have to add 4. Negative 4 plus 4 is 0. Those are eliminated. We have to also add 4 on the left side. If you add 4 on the right side, we have to also add 4 on the left. 12 plus 4 is 16, and we get a equals 16. You can have a equals 16 or 16 equals a. Either way is fine. Let's check this. 12 equals, instead of a, 16 plus, in parentheses, negative 4. Is 16 plus negative 4 equal to 12? Yes, it is. That checks out. Very good. All right, here we have some more practice. Feel free to pause this video and solve each of these. I'm just going to start working through them, so feel free to pause and work through them as needed. All right, we want to get this x by itself. So the way we do that is we subtract 17 from the left, we subtract 17 from the right, and we get x equals 47 minus 17 is 30. So x is equal to 30. We're going to check this. 30 plus 17 is in fact equal to 47, so that checks out. Next one, x plus negative 2. Again, pause this video at any point to work into these on your own. We want to get the x by itself. On the same side of the equation as the x is, we're adding negative 2. The inverse of adding negative 2 is adding 2 to the left and to the right. Negative 2 plus 2 is 0, so that cancels out. X equals 10. I shouldn't say it cancels out. It equals 0. There you go. X equals 10. Let's check this out to be sure. 10 plus negative 2 is in fact equal to 8. I like that. Let's keep going. Ooh, this one. You see how we're subtracting negative 11? We need to change that to v plus 11 equals negative 7. Remember from the test, when you subtract a negative, it becomes addition. The inverse of adding 11 is subtracting 11. So we subtract 11 from both sides, and we end up with v equals negative 7 minus 11. That's negative 18. Negative 18 for v. And let's double check this. V, I'm going to go ahead and change that to addition. Plus, oh wait, I've got v, don't I? Negative 18. I'm going to change that to addition. Plus 11 equals negative 7. Negative 18 plus 11 does in fact equal negative 7. Ooh, this one's a little tricky. All right, negative 5 plus negative r equals negative 17. The inverse of negative 5 is adding 5, so we're going to add 5 to the left and add 5 to the right. And we end up with, keep that negative right there, negative 5 plus 5 is 0. So it's going to be that. So keep the negative with the r there. Negative r equals negative 17 plus 5, and we get negative 12. Now, what this is saying is the opposite of r is equal to negative 12. The opposite of r is equal to negative 12. Or you could think about it this way. Well, by the way, if the opposite of r is equal to negative 12, that means r equals what? R equals 12, right? If the opposite of r is equal to negative 12, then r has to equal 12. You could also think about it as there being a negative 1 in front of the r. And we haven't talked about this yet, but we will. You'll divide by negative 1, and you get r equals, again, 12. Okay, you can plug that back in and check it. Let's do that now, I guess. Negative 5 plus negative r, which is negative 12. Is that equal to negative 17? Negative 5 plus negative 12. Yes, that is, in fact, equal to negative 17. Ooh, here. We're going to combine what we can. I can combine this 4 and the negative 3. You can drop all these parentheses. They're not needed. 4 plus negative 3, that's f plus 1. I was able to combine those, and that's equal to 6. And now we have a pretty simple equation. The inverse of adding 1 is subtracting 1, so we subtract 1 from both sides. And we end up with f equals 5. F equals 5. Well, if f equals 5, let's plug that in here. 5 plus 4 plus negative 3, is that equal to 6? 5 plus 4 is 9. 9 plus negative 3 is in fact equal to 6. I like that. All right. Why don't you go and pause the video now. Try this right-hand column on your own if you haven't done so already. I'm going to breeze through it pretty quick. Give that a shot. All right, y minus 9, the inverse of subtracting 9 is adding 9. So I add 9 to both sides, and I get y equals negative 8. Negative 8. Let's check. Negative 8 minus 9 is in fact equal to negative 17. Next one, m minus 18 equals 3. The inverse of subtracting 18 is adding 18. We add 18 to both sides, and we get m equals 21. 21 minus 18 is in fact equal to 3. If it doesn't check out, that means you made a mistake over here somewhere, and you need to go find your mistake, correct it, and then check again. R plus 73 equals negative 5. The inverse of adding 73 is subtracting 73. Minus 73 minus 73. And we get R equals negative 78. Negative 78, let's check that. Negative 78 plus 73 does in fact equal negative 5. Okay. Next one. Ooh, we've had one similar to this before. There's a negative sign in front of that t. That's okay. The inverse of subtracting 39 is adding 39. So we're going to add 39 on the left. We're going to add 39 on the right. And we get negative t equals negative 21 plus 39 is 18. So the opposite of t is equal to 18, which means t equals negative 18. And let's plug this in to make sure we like it. Negative. T is negative 18, so it's the opposite of negative 18. Minus 39. Is that equal to negative 21? Negative 18 is positive 18. Minus 39 does equal negative 21. So I like that. T equals negative 18. Next one, let's combine what we can. Negative 8 equals h. This is negative 5 plus 6. What's negative 5 plus 6? Positive 1. So h plus 1. We want to get the h by itself. We do that by subtracting 1 from the right. We subtract 1 from the left. And we end up with h equals negative 9. Okay, and then we'll plug this in to check to make sure we like it. I don't know why that keeps doing that. Stop it. All right, last time. Negative 8 equals, instead of h, negative 9 minus 5 plus 6. Negative 8 equals negative 9 minus 5. That's negative 14. Bring down the plus 6. Negative 8 equals negative 14 plus 6 is negative 8. I like that. Very good. All right, so that is how we use the subtraction and addition properties of equality to solve problems. You have a problem set to do of 30 problems. Give your best effort on that. We will go over those tomorrow in class. I should be back. Yeah, just give your best effort on that. That's if you happen to finish early, feel free to work on something for another class. Thanks for watching. Have a great day. Goodbye.